Horse Program is weekly update. Hey everybody, welcome back to the 14th episode of my weekly update videos. Our SQL journey ventures on, and today I will show you some more exercises that I have been working with. So today we will be looking at aggregating stuff from tables in a database. And yep, I got some exercises for you. That's all. The first exercise, we look at a table of all our elements, which has a lot of different data on it. And the task was to get this result. So we want to put all the elements that are in the same period and show which element numbers is contained in this period, an average of their stable isotopes, and all the symbols that are in all the symbols for the elements. So we started off by grouping by the period. So all rows that share the same period, they will be grouped together. And then we took the minimum number in this group and the max number in this group, so we can see from which element number it starts and which element number it ends. And then we took the sum of all the stable isotopes in this period group, and we divided this by how many we could do this maybe by just counting everything, but we should divide this by how many elements are in the group. And we cast one of these data points as a float or decimal or something, so we can get some decimals. And we format the number so it becomes a string with two decimals. And then we do the string agg function, and we take all the symbols and comma separate them and put them as in a column called symbols, like this. Second exercise was to sort out or find all the cities that have at least two customers in a table. We can look at that table, I guess. So we have a list of all the customers for a company, and all these customers are located in some kind of city. So how do we check which cities have at least two customers? Well, we definitely need to group by city, so all the matching cities are in the same group. And then we can basically just select out all groups that have more than two rows in them, I guess, or more than two corresponding things. I'm not sure how to talk about SQL, I realize right now. But I also selected out the region and the country, so it would look nice, and we just count how many things are a part of the group, and we say that they are customers. So we can see that London has 6 customers and Madrid has 2 customers, and we don't get any results showing cities with less than 2 customers. Then we had a nice task how to make a very long Game of Thrones string. And we also have our first example of a variable. So maybe you watched the last week's video. We have a table with all the episodes of Game of Thrones. And we declare a string variable called Game of Thrones string, and we also set the value to nothing in the start, and we basically make a select statement where we make this string longer all the time. First of all, we group the episodes by season. So each season will have its own string. Or am I? Oh, we're just printing this. Darn it, I should record these videos while I'm doing the exercises so I remember what I'm doing. So basically we get a very long string in a variable, and we finish off by printing this string. So what do we have? It will tell us that we have a season, and then we make the season integer into a string, and we got a little space here. And this season 1 in the first group aired from the minimum air date, which is a date time data type, and we format this so we only get the month written out, and we make this lowercase. And so the season 1 aired from June maybe to the maximum air date, which could be July perhaps. No, it should be a couple of months at least. And then we add the year as well. So it will air from a month to a month of the year, whatever the year is in the original air date max. And there was a total of count how many episodes are in this group, episodes in the season, where each episode was watched by an average of the average US viewers, formatted to is it 1 decimal? Yes, million people in the US. And then we add n-char 13, which corresponds to a new line. So let's see what we have here. So this is a very long string, which tells us here that season 1 aired from April to June. There was a total of 10 episodes in the season, where each episode was watched by an average of 2.5 million people in the US. And we get a new line with every season, because we grouped the episodes by season. Yes. And then we had an exercise where we would take this users table, and we needed to concatenate the first name and the last name as a name. And then we needed to tell to get a result which told us how old every user was. So we do this by a dateDiff function and say that we are interested in how many years is between two dates. And we make a date from parts, and we make, yes, I made a string with 19 plus the first two letters from the left in the ID column. So this would become 1950. 1950, which is the year, and then the two letters from place 3, which corresponds to the month and the day. So this we make a date from the different positions in the ID. This is a social security number in Sweden. They look like that. And then we take the difference, we find out the difference between this date, which is their birth date, and today's date. And it will return how many years are between these dates. And then we made an if statement. And so the last thing we wanted to find out is what if they are a man or a woman. Yes, it's a binary thing here. And we look at, let's see here, the 10th, 6, 7, 8, 9, 10. So the last, second to last letter in Swedish social security numbers are either even or uneven. And if this is even, we check this by using modulus 2. If it's even, it's a woman, otherwise it's a man. And we put this in a column called 6. And then I just order this by first and last name. So let's look at what we get here. So we get all the users here, their age, and if they are a man or a woman. Let's see, we have 2 exercises left. And in this exercise, we are looking at a table called countries, which has a lot of countries with a lot of data on them. So the interesting ones are which region they are located in, their population, their area, their area. And that's it. I think these are the ones we use. So first of all, we group these by region, and we select the region, and we get a column called number of countries, which counts all the countries in each region. And then we sum up all of the countries' populations, and we have to cast this as big int or something else, because these numbers are too big to be stored in int. Then we are looking at the total area, So we take, we sum up the area square miles, and we make this into a string. We add an M and an nchar OXOOB2, which corresponds to this little thing, which I don't remember what it's called in English. And then we also are looking to find out the population density per square mile. And what we do here is that we take the sum of the population and divide it by the sum of the area, total area of every country. And it looks something like this. Yep. And then we have the last exercise, which you can see here works pretty good. So this one was pretty tricky. We had a table called airports, which looks like this. And so this data is not very good because of this, the location served. So this is a table of airports, and what it tells us is like both cities and which city it is, and I don't know what this is, maybe a region in the country or something, but the most of this data ends with whatever country they are situated in. So our task was to group this data by which country the airport is serving. So we have to figure out how to get just this part out of this column. And I started out with just taking 3 columns out of this table, because we also needed to do some other stuff. So this is the code for the airport. You guys probably recognize this. The ICAO code, I'm not sure what it is. And I took the location served and I put it into a new table. And then the fun began. So to get these countries out, I first looked at the name of location served, and a lot of these are comma separated and ending with the country. So first of all, I check if there is a comma in the location served column. We should do something, and the thing we should do is also look that if this location served has any numbers in it, which you can find by using a path index function. So if they have an index, if they have a number in it, we should do a couple of stuff. Let's see here. What are we doing here? We are... we can look at this, I think, this statement. So we will replace something in this name, the location served, and the thing we want to replace is this substring, which we get from wherever the number is, and we just take out this number, and we replace this with nothing. So this takes out one number in all of these locations, which has numbers in them. And we also want to take out only the country from these locations served. So we want to take out the so we want to take out from this string that we get here, which has gotten the number replaced, and we want to take out however many letters we get from looking at where the comma is, and I find out where the comma is from reversing this string and looking at the first comma that we get, and then we take out how many however many letters is how many letters that are before the comma, and also the space which is there. So we take -2 here. I'm hearing myself talk, and this is probably not a good explanation, but you can look at this. And if there isn't any numbers in it, we just do this, so we don't take out the numbers first. But this is also contained in an if statement, so if there isn't any commas in it, we do this. We just take out the location served, and we put it in something in a column called country, and we also take IATA and ICAO, and we put it in airports exercise 3. And finally, we can get our result that we want. So we take the country, and we group by country, so we put all countries together, so we can now look at how many airports are in each country, and we can look at how many of these airports are missing the ICAO code. And then we can also look at how many percentages this is. So let's look at this. So we have a group with the United States, which has 2,039 airports. 300 of these are missing ICAO code, and 14.71% of these are missing the ICAO code. The only problem here is that there are also some edge cases which we can do just like this. Hold on. If we order by country, and for example, we have here we have a country called Kingdom of the Netherlands, but these are 2 islands that are in themselves, they are their own countries, so they should be their own countries. But this doesn't fix this, because the country came before the Kingdom of the Netherlands. So I know I could fix this, but I didn't. We also have this one, United States Google Earth view, which we could update if we want to. And we have Western Australia. So that's a reminder to everyone to make your database data better than this. All right. that's all the aggregate exercises I did. And thanks for watching. See you next week. Bye bye.